Hi everyone, it's Emmett from PyMyLifeUp. In this video, we'll be showing you how to set up the Mosquitto MQTT broker using Docker. MQTT is a messaging protocol that has been designed for IoT devices. It is meant to be lightweight and efficient while retaining reliability. An MQTT broker is an intermediary service that handles receiving and sending of messages. For example, you can have a temperature sensor that publishes its temperature on a topic called temperature. You can then have MQTT clients that subscribe to the temperature topic. By being subscribed to this topic, they'll automatically be able to pull the temperature value. The MQTT broker that we'll be setting up with Docker in this guide is called Eclipse Mosquitto. It is an open source broker and is incredibly popular thanks to its lightweight and performance-friendly design. Now, before we go setting up this MQTT broker, you will want to make sure your device has a static IP address. The best way to achieve this is through DHCP reservation, but it can also be done on your device. We'll link to some guides on this below. Once you're ready to proceed, open up the terminal on your device or SSH to it. For the first part of this guide, we will be installing Docker onto your machine. If you already have Docker installed, you can skip ahead a few steps. Now, before we install Docker, let's ensure our operating system is up to date. You can update the package list by typing in sudo apt update and pressing enter. Once the package list has been updated, you can upgrade any out-of-date packages by typing in sudo apt upgrade -y. Now with the operating system up to date, our next step is to ensure that curl is installed to your system. All we need to do this is type in sudo apt install curl -y. We will be using this tool to grab and run the Docker install script, which takes us to our next step. To grab and run the Docker install script, type in curl space -S capital L space https:// get.docker.com space # space sh and then press enter. Once Docker finishes installing, we will want to add your current user to the Docker group by typing in sudo space usermod space -a capital G space docker space $symbol and then user all in uppercase. To ensure your entire operating system is aware of this change, restart it by typing in sudo space reboot and pressing enter. Once your device is turned back on, we can move on to setting up the Mosquitto MQTT broker using Docker. To begin this process, we'll create a directory where we'll store the compose file for the broker as well as its data. Do this by typing in sudo space mkdir space -p space /opt/stacks/mqtt. Once you have created this directory, change into it by typing in cd/opt/stacks/mqtt. We can now begin to write the compose file for the MQTT broker. A compose file is essentially just a list of instructions for Docker to use to set up a particular set of containers. Start writing this file by typing in sudo space nano space compose.yaml. Now, before we start filling out this file, make sure you replicate the indentation that we are using. Indentation is incredibly important to the YAML format. Now start off by defining a new list of Docker services by typing in services followed by the colon symbol. Underneath this, type in Mosquitto followed by the colon symbol. This will start the block where we will define our MQTT Docker container. Next, we'll tell Docker what image we want to download. Type in image colon symbol space eclipse -mosquitto. Next, we will want to give this container a name by typing in container _name colon symbol followed by Mosquitto. The next step is to define a couple of different volumes. Start off a new list of volumes by typing in volumes followed by the colon symbol. Now, define your first volume by typing in -space /config colon symbol /mosquito/config. This will allow our MQTT broker's config to persist between Docker restarts. Next, type in -/data :/mosquito/data. This directory will be used by Mosquitto to store any persistent data. Finally, type in -/log :/mosquito/log. This final volume will be the location where Mosquitto will store all of its MQTT logs. Our next step is to open up some ports from this container to our host system. We can start listing these ports by typing in ports followed by the colon symbol. Now type -1883 :1883 and then -9001 :9001. These two ports are the most common way to interact with the MQTT broker. To secure your MQTT broker that is running within Docker, we will need to generate a password. This will require us to have access to the Mosquitto Docker container. To make this container interactive, start off by typing in stdin _open followed by the colon symbol and then true. And then on a new line, type in tty :true. These two lines will allow us to interact with the container from the command line. Once you have made all these changes, save and quit by pressing Ctrl+X and then Y and then Enter. The next step is to create the config directory where we'll be writing a preferences file for the MQTT Docker container. To do this, type in sudo mkdir config. Now begin writing the preferences file by typing in sudo nano /config/mosquito.conf. When our MQTT broker Docker container starts up, it will read in this file so it knows what ports to use as well as whether authentication is enabled, as well as other options such as persistent data. Let us start by getting it to listen on the ports 1883 and 9001 by typing in listener /1883 and then on a new line, listener 9001. Under the second listener line, type in protocol /WebSockets. This tells the MQTT broker that the previous port defined should be used for WebSocket connections, which in our case will be 9001. Now, let our MQTT broker store persistent data by typing in persistent /true. If this was not set, any data will be lost whenever the MQTT broker restarts. With persistence turned on, we need to set a location for it to store it by typing in persistence _file /mosquito.db. Next, set the location where this DB should be stored by typing in persistence _location /mosquito/data/. The next option allows us to define whether anonymous connections should be allowed. You can do this by typing in allow _anonymous followed by true or false. For this guide, we will be forcing the requirement to use a password by typing in false. If you don't want a password to be required, then simply type in true and then save the file. Since we are enforcing authentication, we need to tell our MQTT broker where this password file will be located. Set this location by typing in password _file /mosquito/config/pw file. Once done, save and quit by pressing Ctrl+X, then Y, and then Enter. These next couple of steps will just show you how you can set a new username and password for your MQTT broker. If you're using anonymous logins, you can skip the next few steps. Otherwise, create an empty PW file by typing in sudo touch /config/pw file. Now adjust the permissions of this file so only the owner can read, write, or execute it. Do this by typing in sudo chmod 0700 /config/pw file. With this file now created, we can start up our MQTT Docker container by typing in docker compose up -d and pressing enter. With the MQTT broker now up and running, we still want to generate that password we talked about earlier. To do this, we need to interact with the container we just started up by typing in docker space compose space exec space mosquito space sh. Now that we are interacting with the container itself, we can type in mosquito password space -c space /mosquito /config /pw file space followed by the username you want to use, which in our case will be PyMyLifeup. You'll now need to type in your password that you want to use to connect to your MQTT broker. Please note, you will need to type in this password twice before it is set. With the user now created, you can exit back to your normal terminal by just typing in exit and pressing enter. Now to get our new MQTT broker to use this new password, we need to restart its Docker container. To do this, type in docker space compose space restart space mosquito. At this point, all you need is the IP address of your machine and you'll be able to start sending MQTT messages to it. Remember, if you have set up authentication, you will need to use your username and password when sending or receiving messages from the MQTT broker. If you have forgotten what the local IP address of your machine is, you can use the command hostname space -I in the terminal. With our example, you can see our local IP address for our device is 192.168.0.8. Now to show that this is all working, we're going to be using an app called Postman. This is a really neat utility that we often use to test our HTTP requests, but luckily it also has support for MQTT. Now, in the address box, we're going to type in the IP address of our device, followed by the colon symbol, then the port 1883. Now, if we hit the connect button, we will run into a not authorized error message. This is because we disabled anonymous logins earlier on in this guide. Now, if we change to the authorization tab and then change type from no auth to basic auth, we'll be able to enter the username and password to authorize ourselves to our MQTT broker that is running within a Docker container. In our example, we used the username PyMyLifeup and the password raspberry. Now if we hit the connect button again, we will see a connected to broker message appear in the response. At this point, you will know that you have successfully set up your MQTT broker within a Docker container. If you have found this guide to be helpful, be sure to give us a thumbs up and subscribe. Until next time, have a good one.